let's review together an example of a logarithmic function and how to graph this by transforming the initial logarithmic function with base 2 of x. The first thing that we need to remember is what is the form of the general logarithmic function, and this is, no matter what the base, log of x is going to meet the x-axis at the x-intercept 1, 0, and this is always, and it's going to have a vertical asymptote, as you can see right here, at x equals to 0, at the y-axis. Okay, that's the first thing. The first thing that we need to look, the first step that we take, is to look inside the argument and to see if we add or subtract any number. Right here you subtract 3. If you subtract a number, then you move to the right. If you were adding 3, you would move to the left. So by moving to the right, what is affected right here is the curve that shifts to the right by 3 units, the x-intercept that from what it was before 1, 0, now it's going to be 1 plus 3, the number of units that we add, 0, and the vertical asymptote, that it was x equals to 0, but now it's going to be x equals to 3. So the new curve that I will get is this, that is similar to the previous one, with the difference that is shifted to the right by 3 units. Vertical asymptote is affected and x-intercept is affected. The next step that I have to take is to look at the sign in front of my x inside the argument. The sign right here is plus. Since it's plus, I do nothing. If this was minus, then I would need to rotate around the y-axis. But I don't do that. I don't rotate around the y-axis because it's plus. So in this step, my curve remains as it was at the end of step 2. The first step, I look what I add or subtract inside the argument, and then I look at the argument and I look at the sign of x. The fourth step that I have to take is to look at the sign in front of my logarithm. And the sign in front of my logarithm is minus in this case. This tells me that I need to rotate my logarithm around now the x-axis. So this means that instead of my logarithm going up, this time the logarithm will go down like this. It will have the same vertical asymptote and it will have the same x-intercept. So it's going to be, the curve is going to become like this. The vertical asymptote is not affected. The vertical asymptote is defined only by k, nothing else. So it's set. And the x-intercept is going to be not affected by the rotations. Okay, so now the only thing that remains is to look at the plus 5, the number that I add to my logarithm. Either add or subtract. And this, as always, is going to affect how many units I shift up or down. In this case, because I have a plus, this means that I'm going to shift up. So I will shift up my curve by 5 units. Now, the issue that I have is because I have a vertical asymptote, and this vertical asymptote doesn't allow for my logarithm to cross the y-axis, I cannot use the y-intercept in order to determine one of the points of my log. So I know that my log will shift up, and this will affect the x-intercept. But I'm not exactly sure how this will happen, since this effect, it will be based on the number that I add, the plus 5, but also the logarithmic base, that is 2. So I do know that I start with this from step 4, and I do know that this needs to be shifted up, but I'm not quite sure where this will cross the x-axis, and I need to find a point. How do I find a point? Well, I need to set the x equal to a number. The number that I can choose for my x can be any number, but I need to be careful here. The best number that I can choose should be a number for x such that will change the argument into the base. So what I want is to choose an x such that will make the x minus 3 equals to 2. So if I change my x here to 5, then 5 minus 3 is equal to 2. And in this case, the log of 2 is going to be 1. So if I look right now at my logarithm, and let me write up here for you, I will have negative log with base 2 of 5 minus 3 plus 5. And this is going to be negative log with base 2 of 2, that is 1, plus 5. So this is going to be equal to 4. So this means that my intercept will be, when the x is 5, right here, then my function will be equal to 4. So one point of my function, let me make this point blue, will be this right here. So my function, my curve, will have the same intercept, the same asymptote, vertical asymptote. It will move in the same way as before, but it will cross the x-axis much further to the right than before. Let's continue this problem and see it in a clearer screen. So, I know that the vertical asymptote, as we checked before, is going to be the x equals 3. What I don't know yet is where my curve will cross. Also, I found a point, as I said before, when x is equal to 5, then x minus 3 is equal to 2. So when x is equal to 5, the f of x, the f of 5, is equal to negative log with base 2 of 2 plus 5, that is equal to 4. So I get the point 5,4. Now, it would be good to know also the x-intercept. What is the x-intercept? The x-intercept is where the x, what is the x when the f of x is equal to 0. So what I need to do basically, in order to find this point, is to solve the actual logarithmic equation. The equation that I have is this. So I want to set this equal to 0 to find the x. In order to do that, I need to pass my logarithm on the other side, and I have log with base 2 of x minus 3 equals to 5. And I need to solve this equation. Remember, in order to solve logarithmic equations, I need to have logarithms on both sides with the same base. So I need to rewrite the number 5 as a log with base 2. So 5 is going to be the exponent of 2 for the log of 2 to the 2 to that exponent to be equal to 5. So basically, what I need to have right now is to rewrite my logarithm on the right side instead of 5 as log with base 2 of 2 to the 5th, because this is nothing else than 5. And this gives me that x minus 3 is equal to 32. That is 2 to the 5th. And this means that x is equal to 35. So the x-intercept that I get is the point 35, 0. What does this mean? This simply means that my curve is going to cross the x-axis at the point 35, 0. So if I want to graph my curve, the curve will look like this. The curve will look like this. As you can see right here, the x-intercept for my curve is going to be at point 35, 0. The curve will continue under this, and the vertical asymptote is at x equals to 3. Now, the domain for this function is going to be from 3 to positive infinity, while the range will be the same as for any logarithm, and this is going to be from negative infinity to positive infinity.